Factoring polynomials. Factoring polynomials and solving polynomial equations. There are four topics we want to discuss in this lesson. First, vocabulary. Second, know that multiplying and factoring are inverse operations, or a process in reverse. Factor a trinomial in the form of 1x squared plus bx plus c. And then also let's factor using the difference of two squares. First, factoring. Factoring is the process in finding the quantities that are multiplied together to obtain the product. So for example, if I say, what are the factors of 6? You would say 2 times 3, or 1 times 6. Those are quantities that can be multiplied together to get the product. A prime polynomial. A prime polynomial is a polynomial that cannot be factored. Please pause the video if you do not have all the vocabulary words written. Now this is a bit of review. We talked about this in the last lesson. Multiplying and factoring are inverse operations. So for multiplication, if I take these two binomials and multiply them together, x plus 2 times x plus 3, and it equals x squared plus 5x plus 2. Well, to factor, I would go from this quadratic back to these two binomials. So multiply goes in this direction, while factoring just goes back to the two factors. So to refresh our memory about multiplying polynomials, when you multiply polynomials and two binomials, you FOIL. And FOIL, remember, stands for first terms, outer terms, inner terms, and then the last terms. So x times x is x squared. X times 2, 2x. X times 3, 3x. And then 3 times 2, 6. When you combine like terms in the middle, we get this quadratic. Well, there's something to pay attention to and to notice. If you notice, 2x plus 3x gives us our 5x. And also notice that 2 times 3, or 3 times 2, gives us our product. So, knowing that, we're going to look at this polynomial here, and we're going to factor it. So what we need to find out is what two integers have a product of 24, and those same two integers have a sum of 11. So the product of 24, same two integers with a sum of 11. Now, to go back one screen, remember, our sum came from the two numbers we added in the middle, the sum of these numbers. The product came from my constant term, and it's the product of those two numbers. So, if you list all the products that give you 24, 1 times 24, 2 times 12, 3 times 8, 4 times 6. Only one of these has a sum of 11. That's 3 and 8. So that means my factors will be or x plus 8 and x plus 3. It's important to understand that the reason why it works the way it does for the last problem is because this leading coefficient is 1. If this leading coefficient is not 1, we'll learn in the next lesson what we need to do. But because the leading coefficient is 1 here, that means that we can just do the product sum. So we'll do another problem so we have a better understanding. Let's factor the following. I'm going to factor the first one, and I want you all to pause the video and factor the next two problems. First, what could you multiply together to get 21? Those same two numbers add together to get 10. So P stands for product, S stands for sum. So what product is 21? What sum? 10. So I need to pick two numbers. So I want to go through what are the products of 21. Well, or the factors, I'm sorry, that will give me 21. So I can do 1 times 21, but 1 plus 21 is not 10. 3 times 7, 3 plus 7 is 10. Those are my answers, 3 and 7. So my factors must be x plus 7 times x plus 3. Please take a moment to pause the video and work the next two problems. Okay, first, product sum. The product will be negative 18. The sum will be negative 3. So what can you multiply together to get negative 18? Those same two numbers add together to get negative 3. And I think negative 6 and positive 3 would work. So my factors are just x minus 6 and x plus 3. The last one. Product, negative 20. Sum, positive 1. So now what can I multiply together to get negative 20 and add together to get positive 1? Well, I think 5 and negative 4 will work. So my factors are x plus 5 times x minus 4. Now, giving a polynomial. If your polynomial is not in descending order, meaning it starts with the highest degree and works its way down, you need to first rewrite the polynomial so it is in descending order. And now we do product sum. Product, negative 14, sum, 6. So this is a hard one to see, so let's write down all the product of negative 14. So I have 1, negative 14, negative 1, 14. 2, negative 7, negative 2, 7. None of these can I add together and get 6. So that means it is a prime polynomial. Next thing, difference of squares. Now we reviewed this earlier in the chapter and a little bit last chapter as well. So difference of squares. If you were to do product sum like we did before, you would say my constant term is negative 81, and then the sum is hard to see. So my product, negative 81, my sum is actually 0 because this is x squared plus 0x minus 81. So the sum is 0. So what can you multiply together to get negative 81? Those same two numbers add together to get 0. Well, 9 and negative 9. So my factors are x plus 9 times x minus 9. Notice, this is the difference of squares. So if you remember before, in an earlier chapter, we multiplied these when we FOILed. These are binomial conjugates. And when you multiply binomial conjugates, what you get is the difference of two squares. So if you notice, the first term is the square root of the first term. The second term is the square root of the second term. And one is addition and one is subtraction. So follow that same pattern and try to work the next two problems. Please pause the video. Okay, so the square root of 4y squared is 2y. The square root of 25x squared is 5x. So my two terms will be 2y and 5x. And because it's the difference of squares, that means I will have one addition and one subtraction. They'll be binomial conjugates. And the last one will be so sometimes you'll have to factor out the greatest common factor before you can do product sum. But you want to always make sure you factor completely. So in this case, I can factor out a 3 from each of my coefficients and an x from each of my x terms. When I do that, I'm left inside the parentheses with this. And now I want to check inside my parentheses with this quadratic, can I factor by using product sum? So the product is 12, the sum is 7. What can I multiply together to get 12? Add together to get 7? Think 4 and 3. So my factors are going to be, and don't forget, one of the factors is this first term, 3x. You factored it out already. 3x times x plus 4 times x plus 3. Again, factoring out the greatest common factor. Well, I can factor a 5 out of each of the coefficients. I can factor out an x from each of the coefficients and a y squared, from each of the x terms, and a y squared from each of the y terms. So in doing that, what am I left with? Now this is tricky because you have two variables here. So you have x squared here, xy here, and y squared here. Well, remember, in order for us to factor this, we want to treat this like a constant term and treat the 2x like a constant term. Look at it in terms of the variables only being x squared and x. So now let's do product sum. Since my leading coefficient is 1, the product is negative 8y squared. The sum is negative 2y. So what can I multiply together to get negative 8y squared? Those same two numbers add together to get negative 2y. Well, I think it would be negative 4 and positive negative 4y and positive 2y. So my factors are, first, the amount I factored out, and then what was left was x minus 4y times x plus 2y. Now lastly, if the leading coefficient is negative, the first thing we want to do is factor out our negatives. We do not want a leading coefficient to be negative. Next, once I factor out a negative 2r squared, then we want to use product sum. And what can you multiply to get 20? Add together to get negative 9. So the factors are Hi, please complete the homework out of lesson 6.2. Thank you.